So we are done with the electric current. We defined it. We discussed the measurement of an electric current, including the device used, which is the multimeter used as an ammeter, the connection of the ammeter, the scale, the representation, and so on. Now we'll have to talk about the other physical parameter, which is related to electricity. It's the voltage. So after watching the video on YouTube, after watching the video whose link is the one shown here, we're going to see that the definition of a voltage is it's the voltage across an electric component is the electric energy per unit charge that drives or forces the flow of an electric current across its terminals. So we know that the electric current is the flow of charges. So what causes these charges to flow? They need some force, they need some source of energy. This is present in the battery, for example. So here is an analogy between a water system and an electric network. If we consider an electric network that is supplied with a battery and another water system that is controlled by a pump. So here the pump and the battery function the same. The pump presses on the water, causing it to flow through the circuit. So it exerts a force on the water, causing it to flow. Similarly, here the battery having energy exerts a certain force on the electric charges to flow through the circuit. So devices like electric cells and other electrical energy sources act like a pump, pushing the charges to flow through a wire or a conductor. Now, measurement of voltage. Multimeter is used as a voltmeter. So last time, or for the electric current, we discussed that the multimeter could be used as an ammeter if the scale is adjusted here in this range where the unit is ampere. So when the multimeter is adjusted in this range of scale, it is used as an ammeter because the unit is ampere. Now if we adjust it within this range where the unit is V, as you can see here we have V for direct voltage and V with this symbol for the alternating voltage. Anyway, if it is adjusted within this range, then it is used as a voltmeter. Now, how is it connected? It is connected in parallel, unlike the ammeter. The ammeter is connected in series. It has two terminals, a V terminal and a COM terminal. The V terminal is the positive terminal and the COM terminal is the negative one. The symbol is a circle with a capital V, and we have to show the COM terminal. Now with direct application, choose the most convenient scale to measure a 30-volt voltage. We said before under the title of electric current that the most convenient scale must be equal or slightly greater than the measured quantity. So similarly here for the voltage, if we want to measure 30 volts, we need to check the available scales. We have 200 millivolts, we have 2000 millivolts, 20 volts, 200 volts, and 250 volts, as you can see them here. Okay, this range, because now we are going to deal with direct voltage in which the battery is the source of voltage. So we have from 200 millivolts to 250 volts. Now, of course, to be able to determine the convenient scale, we have to convert it to the same unit of the measured voltage. The measured voltage is in volts, so now we need to convert millivolts to volts. In order to convert from millivolt to volt, we have to divide by 1000 or divide by 10 power 3. It's 0.2 volts. 2000 millivolts divided by 1000, 2 volts. And why is it 2 volts? Because dividing by 10 power 3 means moving the decimal point backwards by 3 digits. So it's 1, 2, 3, 2 volts. 20 volts. 200 volts are already given in volts, and 250 volts. Now we have to check the ones that are greater than 30. So 0.2 volt and 2 volts are going to be excluded. We have also 20 volt is going to be excluded because it's less than 30. So we are left with 200 volts and 250 volt. So which one is slightly greater? The nearest one is 200 volts. So using this, the most convenient scale is 200 volts because it's the one greater than 30 and the closest to it. So using this multimeter, 200 volt is the most convenient scale for measuring a 30 volts direct voltage. Now the sign of the reading indicated by the voltmeter depends on the connection of its COM terminal, just like the sign of the indication or of the reading indicated by the ammeter. So to obtain a positive reading, again, we have to connect the COM terminal of the voltmeter to the negative terminal of the electric component. In this case, as you can see in this figure, we have the electric current coming out of the positive terminal of the battery. So it passes through the lamp from the right to the left in this case. That's why we say that this is the positive terminal and this is the negative terminal of the lamp, because the current goes from the positive to the negative through it. So now we have that the COM is connected to the negative terminal of the lamp and the V connected to the positive terminal of the lamp. So this is parallel grouping or parallel connection because two terminals are connected to two terminals in the first place. And in the second place, the reading is positive because COM is connected to the negative. So we have negative connected to the negative. Now concerning the negative reading, so here we have to do reverse connection, but of course keeping it connected in parallel. So when the COM terminal of the voltmeter is connected to the positive terminal of the electric component, the reading indicated by the voltmeter is negative. So as you can see here, we have two terminals connected to two terminals of the lamp, but now the COM is connected to the positive terminal of the lamp. So we have negative connected to positive. That's why we obtain a negative reading. Exercise. So we have a circuit, an open circuit here. This is an open switch. A circuit that's made up of a battery that provides a direct voltage, a lamp, and an open switch, of course connected using connecting wires. Does the current pass in the circuit? If no, what should you do to make the current pass? So no, the current doesn't flow through the circuit in this case since the switch is opened. So the current won't find a way to pass through. The switch in this case must be closed to allow the flow of current. Where should we connect the terminals of a multimeter used as a voltmeter in order to measure the voltage across the bulb? When you're asked to show the representation of the connection of a voltmeter and without specifying whether we want to obtain a positive reading or a negative reading, this means that you have to represent it in a way that it indicates positive reading. Otherwise, you must be given that we need to have it or to obtain a negative reading. So for the lamp, the positive terminal of the battery in this case is here. The current is going to flow anticlockwise from left to right through the lamp. So this is the positive terminal of the lamp and this is the negative terminal here. And we have that the COM connected to the negative and in parallel across the lamp. So this is the correct connection of the voltmeter or through across the lamp or across the bulb. And for the switch as such, the switch doesn't matter concerning the switch because it acts as a connecting wire. A closed switch acts as a connecting wire, so the voltmeter is going to indicate 0 volts. So it doesn't matter whether we connect COM to this pole or to the other pole because the two terminals of the switch are identical. Finally, concerning the dry cell, in order to obtain a positive reading, we have to connect, as you can see, the COM terminal to the negative terminal of the battery and the V terminal to the positive terminal. Now fill in the blanks with the convenient word. The voltage between 2 points of a circuit is measured by a multimeter used as a voltmeter. Such an apparatus is connected in parallel between the 2 points and the unit of voltage in SI is the voltage and its symbol is capital V. Copy and match. Unit of current, we have it as milliampere. Measures the voltage, it is the voltmeter. Measures the current, the ammeter, and unit of voltage is the volt.